Hi, I'm Richard, and in today's tutorial we're going to use Unity to create the Feigenbaum graph here. So let's get started. Hello and thank you for watching. Today we're going to tackle something called the Feigenbaum constant. Now, the Feigenbaum constant was created by a guy called Mitchell Feigenbaum. He had a series of functions, actually constants, whereby you reiterate a function over and over again to get to a value. I think the idea was that it would be used for population estimation and growth and various sort of calculations to get those. And he came up with one of those, I guess you call them, infinite numerical values like pi that seems to go on forever and with no repeating. So the way we're going to actually do this, by the way, I found this on a number file video. If you don't watch number file and you like this kind of stuff, you should definitely be watching number file. One of my favourite things to watch. It's one of those kind of channels that doesn't overload you with too much math. Sometimes it gets a little bit heavy, but you always feel that if you could take it on. Some of this stuff, for instance, I would never have looked at this kind of thing. I would have looked at this and looked away and gone, that doesn't make any sense to me. But thanks to number file, I'm prepared to give it a go. We're going to try and create this something like this graph here in Unity. Alright, so first of all, let's just take a look at what this calculation is, what this function is here. Just ignore these two down here for a second. We've got this x n plus 1 is equal to xn times this weird symbol times 1 minus xn. Okay, well, crikey, that's a lot to go through, isn't it? But don't worry, it's not actually as complicated as you might think. The n is the current number, if you like. So if we have a starting value, as I've set here, to 0.5, okay, so what we're going to say is the next one will be the current one, 0.5, times this, it's called lambda, and then times by 1 minus the current value. So if the current value is this, what we can do is we'll say this. We'll say xn plus 1. Just put that there, and we'll just say equals. Let's open the brackets. So it's going to be that times that times 1 minus that again. All right? And that'll give us a value. And here we've got a value of 0.625. Wonderful, I hear you cry. There's one thing that we should do. We should keep this here in X is XL, so excuse me. So that's B5, is it? So let's just put $B, $5. If you don't know what that is, don't panic. I'm just working these things out. Right, so that's got that value now. Okay, and what we can do now below it, I think, actually, I might have to do it one more time, equals, open brackets, that times that, close brackets, times 1 minus that again, yeah? So we're kind of doing the x, this is n plus 2, right? And you've got 0.5898 and so on. So, and what we should be able to, I'll probably have to do $B, $5, $B, $5, yes, to make sure we know. And now if I drag this down, okay, so you can see these numbers are going up and down, right? If I just drag this down a few more, you can see that it's kind of leveling out. If I keep going, you can see that eventually, what I might do as well, is just adjust the number. Be kind. Hang on. If I just do that and then just pull that out the wrong way. There we go. You can see eventually, in this example, when lambda's 2.5, it settles out eventually at 0.6. Let's try 2.6. Change it. And you can see again, eventually, after a little bit of looping around, so this is n plus 2, n plus 3, it sort of constants out at about 615,385. There we go. And this was kind of, I think this was the way it was working. It was people thought, well, it just settles down after a while. That's absolutely fine. But what's interesting is if you start to go to something like 3.1, now this will start monkeying around. What I might have to do is just drag this down a lot further. And what you'll see, here we go, is actually now it's gone to 2 numbers. So as this number goes up to 3.1, if we go down the very bottom, it's actually got 2 numbers. And if you see here, so if you imagine that lambda is on the x-axis here, you can see that it's kind of, as the number increases, this goes out, and then all of a sudden it goes to 4 different values, 4 different floating point values. Okay, and this is what Feigenbaum found. And the Feigenbaum constant, by the way, is the distance, or sort of the ratio between that distance there and that distance there, and the one below it and the one below it. Okay, and that gives us this. Where's my thing on here? I'll close that down. That gives us this 4.669201. We're not going to concern ourselves with that too much. we're really interested in creating this funky little diagram here. So it should be quite straightforward for something like Unity or any computer program to do this. Well, we'll loop through a kind of a lambda, maybe starting at 2.5. I can tell you that once you get to about 3.6, it goes nuts. In fact, again, if I spin back to this, where's my thing here? You can see, I think here, let's put that bigger, here is around about 3.5, 3.6 here, and that's where it starts just to go completely bonkers. It doesn't seem to settle down. Curiously, there's this little gap here. There's definitely some weirdness going on. I invite you to have a good look at this and play once we've got this done. Alright, so I hope you're enthused to give this a go. Sit with me. I've had a little go at this earlier on. So let's get into Unity. Let's create a new project. And we'll call this, what should we call it? I clicked new, didn't I? Yes. Make sure you click on 2D. And we will, we'll call it Feigenbaum tutorial. How about that? Feigenbaum tutorial. I'll put a link to a Unity package that we can use later on. Feigenbaum tutorial. Let me sure I spelled it right. Feigenbaum. It'd be terrible to spell it wrong, wouldn't it? There we go. 2D create project. Okay, I'll let that create. How's everyone doing? I'll have a quick sip of my tea while that's doing that. Quick sip, I say. Here we go. I think I've got the latest version of Unity. I've got a version of Unity. So first of all, let's create ourselves a utility script that we can use to help us out. Come on, there we go. So let's just create a folder. I don't know why I'm going to create a folder, but I'll create a scripts folder just for the hell of it. Alright, and within that scripts folder we'll create our C# script. What should we call it? We'll call it Feigenbaum utils or something like that. Feigenbaum. Could have called it something a bit more friendly, couldn't he? Feigenbaum utils. There we go. And we'll click in this. This isn't going to be a mono behavior. This is going to be a bunch of static classes that one of our mono behaviors can call. Because what we're going to want to do when we do this, like I say, where's my Excel spreadsheet gone there? As these numbers get higher, it takes quite a long time for these to settle down into something meaningful. So we're going to have to run this iteration quite a lot, and then at the end we should have, 3 or 4 outstanding values, if that makes sense. Outstanding values, unique values. Let's make that a bit bigger. I know you like it bigger. Okay, is that big enough or too big? Right. So we don't need start or update. We don't need mono behavior. We just want this to be a Feigenbaum util. So let's have a couple of static methods. So first of all, we'll say void static float get next Feigenbaum number, and we're going to want a lambda, and we're going to want a float. I think that value, the x, is meant to be a population. I think, yeah. So we'll call that float. Let's just call it float x to keep it consistent. Please feel free to use something else. I know some of you are probably thinking, Richard, you're not naming these correctly. Is that all we need? It is, right? So now what we need to do is we need to say return lambda times x times type open brackets 1 minus x. That's a good start, isn't it? So that gives us, if you like, where's our spreadsheet here? As we go down here, you see that would give us the next number from the previous number. All right, that's good. While I'm at it, gosh, I've got too much loaded. I have to close a few things down. So we don't need this. We don't need anything with Unity. We can no, we may need the system. Let's just get rid of that one. Okay, and now then, if we're going to kind of get these variables, let's have a method that does that as well. So static float get Feigenbaum set. Feigenbaum set. So this is going to return a set of numbers. Obviously, initially is 2. So like I say, if you did number 2, it would only return one number. Actually, I should do 2.2 or something. Yeah, you can see it's only going to return 5455, right? But if the number was 3.3, I'd imagine towards the end, I'm hoping, there you go, you can see it would return a couple of numbers. So this is actually going to return a float array, isn't it? Get Feigenbaum set. And also it's going to have a lambda, and it's going to have an initial starting value, so we'll call it float start x, and let's just allow us to define the number of times this is going to run. So we'll call this iterations. Okay, stick with me on this. If this isn't making sense, maybe it will in a minute. So what we need to do is we need to run this, let's say 1,000 times, and then after that we'll take the last 50 values and put them in a unique set, so that if there is only 2, that set will only be have contained two values. All right. If you know how sets work, sets don't let you have. Well, sets will only have a unique value in them. Okay. This is a little bit fiddly with floats because I know floating point operation can sometimes mess you about, but I'm hoping that we can get away with it to some degree. Let's try. So what we'll say is what for brackets. Let's do this for int I equals 0. I is less than iterations, so that's how many times we're going to run it. I plus plus, and then so up here we'll just say float initial current value equals start x, right? And then we'll say start x equals get next Feigenbaum number lambda comma start x, right? Because we're passing the value that was we're going to overwrite it every time, right? That's going to do it. That'll run 1,000 times or something like that. All right, and that'll return us a set of values. Well, it won't return us a set of values, will it? That'll just give us a start x. It's effectively, in fact, we don't even need to store the value. Oh, yes, we do. Yes, we do, because it's changing. Sorry, I'm talking out loud. Right, so now with that in mind, what we could do is we can now say for brackets int I again equals 0. I is less than, I'm just going to pick a number here, 100. Yeah, okay, bear with me on this. Okay, we'll do a little test, right? And then I plus plus, sorry, excuse me. I plus plus, and then we'll say current value equals get next Feigenbaum number. Same deal. You think, well, you run it twice. Well, the first time, this is to kind of get it to settle down, and now we're actually going to store the values at the end. Right? This is the sort of settling period while it sort of finds its level, and these are the ones hopefully that the thing is going to be the iterations, particularly as the number goes up. You need to run a lot of iterations for it to settle down. The lower the number, the quicker it settles down. Right. So let's just do current value, and what we'll do up here, let's create a hash set of type float. Values equals new hash set. Oh yeah, hash set float. There we go. Thank you, MonoDevelop. All right, and now we can say values.add current value. Now, with any luck, what this is going to be doing is it's going to, the number is going to be the same over and over again. So this values.add is not adding any value. There we go. It will stay the same. Now, I can say there could be some annoying anomalies either side of the value because of the sort of floating point operations, but shouldn't matter too much because when we get to convert these into pixels on the screen, hopefully it'll round up or round down appropriately. I don't really mind if there's a little bit of edging. I'll let you have a play and see if you can fix that. So if we just go down here, and what I might just do is now say for brackets in I equals, no, hang on, yeah, I equals 0. No, we need for a hash set. You need to say for each, isn't it? For each float value in values. Is that how you do it? Is it in values? Excuse me, I'm so used to using Java. That's right. And then we'll say debug.log value. It's not happy, I can tell. If we just shift Control S that, bear with me, I'll just find the exact logic. Second. Excuse me, I know what the problem is. So now I need to put back Unity again using Unity Editor, Unity Engine, and that will come back in. That's annoying. So we'll have to. I'm only doing this for testing purposes. So let's just quickly add a void start. Squiggle. We need to make it extend mono behavior, don't we? This is annoying, but it'll help us test it. Oh no, let's do it properly. Let's crack on the way we intend to, right? This is going to now return a float array. Now at the minute we've got a float set, so I think what we can do is we'll say float I don't know, values, return values equals new float, and it's going to be values dot count, isn't it? Yeah. And then we say values dot copy to return values, and finally return values, right? Gosh, that was more complicated than I thought it was going to be. How are we looking? Are we recording still? My dreaded fear. Yes, we are. Right. So what we're saying is here, run this many times, and then when you finish that, set up a set. Get the hopefully settle down values and add them into this set here. There shouldn't be many. There might be depending on whereabouts we are, but hopefully no more than 100. And then copy that set to it, and that should be a nice small set, and return that in. Right. Okay. Good. I'm pretty comfortable with that. So let's just save that. Go back into Unity and see if it's throwing any errors on me. Nothing yet. Interesting. Let's set it to 16 by 9. Okay, I don't see any errors. That's a very good start, isn't it? So let's create another script called we'll call this Feigenbaum. I'm going to call this badly, and I hate that when I do that. So we'll call it Feigenbaum. Feigenbaum. Come on, Rich. What we're thinking? Feigenbaum texture. Right, let's call it that. That's okay, because this is going to be the one that's going to store the texture later on. So now if we go into this one, do not send. Why does MonoDevelop do this? Right, apologies. I will restart it and come back to you. Welcome back. I have a feeling, that happens whenever you double-click a second script. Now I could be wrong, but that's the way it feels. Right, so we don't need to update right now, but let's just not worry about moving it. We're going to say something along the lines of float actually, let's put that outside, shall we? We're just going to play around with this for now. Lambda equals 2.2 f, and the population. I've noticed when this happens, we do tend to want it to be 0.5. Where's my other one gone? Here we go. Here it is. Yeah, so let's go back into here and let's just set this to let's call it x as well, equals 0.5 f. All right. So with that said, we can start putting the values into start, making a call here, and let's just get it to output to the console the exact values. Let's try that now. Right. So what we're saying start is Feigenbaum utils dot. Excuse me. Why hasn't that done that? Static float. I've saved it, right? I think static should be there. Should be saying Feigenbaum utils dot reference equals. Come on. Why isn't that showing? Any errors? Maybe. Hang on. Let's go over to here. Yeah, Feigenbaum texture is not going to work because I've just messed that up there. So let's just try that. Any errors still? No, so that's working there. So why isn't that working? 1 second. What am I doing wrong here? Static float. Let's make them public. That's probably what it is. Public. Sorry, being a fool. I thought it would let you do it. I work in Java world. This is the problem. Keep doing that as well. Control tab. Now let's try a Feigenbaum utils dot. There we go. Get Feigenbaum set, and we'll say it's lambda, comma x, comma, and we'll pick what? Should we say 10,000 iterations, right? And then we'll just do debug dot log lambda equals quotes plus lambda, and then for brackets int I equals 0 semicolon I is less than. Hang on. So you say float values. Is that right? Why is that got a funny colour? I is less than values dot length I plus plus, and we'll do something like debug dot log brackets and do a couple spaces and then lambda, and then values I. Alright, so what that's going to do, that's going to just run through and find us our value based on 2.2. So let's try this now. Back to here. Any errors? No, and we'll create an empty. Lovely, and get our Feigenbaum texture and just pop it in. And we know it's not doing much at the minute. So if we run this, sorry, let's click off that and just pause it and unpause it. Click on console. And there we go. You can see it's got 0.54546. It's just got the one value. So let's just try another value. Let's just try 3.2 or something. Oh, not 2.3, 3.2. that's annoying. That's also only got one value. Okay, so we'll try 3.3. You can see in a moment that it will have more than one value. I'm going to move the console up to this up here so that that's curious. Okay, I'm going to keep going. I thought let's try 3.4. Something gone wrong here. Come on now. Come on now. Okay, so we'll just try 3.5. Now I'm getting nervous now. Okay, so something is a bit weird. Bear with me 1 second. Yep, I can see my bug. You probably have seen it too. I should be put star text, so that should be current value equals get next Feigenbaum number. So sorry about that. That's what it was. So let's give it another try. Control S. Am I recording? Yes, I am. Okay, so let's spin back to here. Bugs everywhere. Okay, let's try it now. 3.5 should produce 0.875. That's interesting. Have I saved it? Current value equals get next Feigenbaum number. Current value. Oh, look, there should be current value as well. And that one. If you keep doing start X, it's going to give the same value, isn't it? Right, sorry. There. Gosh, I made a right mess of that, didn't I? I hope that didn't confuse you too much. That's better. 1, 2, 3, 4 numbers, you see? So you've got four possible things as you approach 3.5. And as you approach 3.6, I'd imagine if I put 3.6 in here. Okay. You start to get a whole load of numbers. It doesn't really settle down very well. I think 3.6 is. I think things start to get chaotic at 3.6. Something like 3.55 is where things start to mess up. But let's find out where that is. Right. So we've got our kind of system now that can go through and add these values here. So what we should do is create a texture. And in that texture, we'll move through 1 pixel at a time and find a value for it. So we're going to have to do a little bit of calculations to work out what point we are. First of all, then let's go into our Unity here, and we will pop back to the scene view, and we'll create let's create a plane, a 3D object, a plane, and we'll just make that rotation minus 90. Right, and what we need to do as well is create a material for it, because we're going to be creating a texture. So we'll just create a basic material, create material. PF2, so we'll just call it standard material, and we'll just apply that to our plane, which seems to be under the game object, which we don't want, so let's pop it there. In fact, we'll delete our game object now. So we're going to be using this plane here as our graph to draw the Feigenbaum. What do you call it? Fractal. I don't know whether it's a fractal or not. We should probably maybe have a little play around to see if it is a fractal. Right, so let's initialize that texture. We can do this back in our script here. So we'll attach this Feigenbaum texture to our new plane, like that. And then what we'll do, you have to bear with me while I remind myself how this works. 1 second. Back to there we go. And now here, so we can get rid of this for now. Or at least let's just do that, something like that. // Okay. So we want to initialize our texture, so we'll have a void initialize texture, and we need to have a texture 2D here. We'll call it texture. Right, let me just quickly remind myself how we do this. Okay, so first of all, hang on, let's just not sure why I end up putting a semicolon there, and let's put initialize texture in here so we don't forget to run it. And we'll say texture equals new texture 2D. Let's put width, height, and we'll set that as variables at the top. Well, just for now, we won't keep them public. We'll just make them local. Int width, we'll say equals 512. Int height equals 512. Right. Okay, texture 2D equals new texture, and then what we'll do is we'll say for brackets. We need to set the renderer to it, don't we, as well? So let's do that. And how do we do it? Get component renderer renderer dot. That's probably that, isn't it? Main material dot main texture equals texture. I think that's how you say it. I could be wrong. We'll find out in a minute. 4 brackets int w equals 0. W is less than width. W plus plus. And then we'll do the same for the height. 4 brackets int h equals 0. H is less than height. H plus plus. And what we say here is we'll say texture dot set pixel w comma h comma I don't know, let's say color dot blue. Let's just try something that we know is going to be out there. And once we've done that, we'll say texture dot apply. Right, so this is going to initialize our texture, give it a blue background. Blue's fine for now. We just want to see if that actually works. Is it going to throw any errors? So we've got our console. Clear that, and we'll run it. Run it. And it's gone blue. Fantastic. How about that for a first time? I did that from memory. These are the sort of things that I don't know how on earth I remembered. So good. So you can see we've got our way of setting the pixels. So what we'll now do, we can tweak this later on, but we need to think about how we're going to set these values. Bear with me while I have a sip of my tea. There we go. Do love a cup of tea being British. So what we'll do is we'll have another variable called void create Feigenbaum graph. Right, this is going to get pretty sticky now. So we're going to say, actually, let's not call initialize texture there. Let's call it in here. Okay, I think there's going to be another slight issue, but we'll get to that in a second. I think we're going to have a bit of a problem. We need to do a bit of multi-threading to make sure that we don't completely lose control of the window, because it'll just take forever to run. So we're going to say so we'll have float start val, and we'll start. Should we start it at let's start it at 2f, and then we'll do float end value equals 3.3f. Okay, so what I'm saying here, these are the lambda values. Okay, we're going to start at 2 and go for 3. Now what we're going to do now is we're going to say so also we can have float increment values equals end val minus start val divided by width. Okay, so what we're saying here is that each pixel to the right, each pixel on the x-axis is going to be we're going to increment the lambda by that much. Okay, and then we'll get our y value by getting the what was it? The Feigenbaum. Then we'll run this get Feigenbaum set for that, and we'll draw those pixels. Okay, getting a bit scary now. Hope you're with me still. So we'll say 4 brackets int w equals 0. W is less than width. W plus plus. Squiggle. All right. Then we say. What do we say? we say so float lambda equals start val, that's it, plus brackets increment values times w. Is that going to be kind? Okay, can you see what we've done here? So we're saying each pixel along, okay, our lambda is going to go up by a certain amount based on the width. Okay, so we've divided that by 512 to give us each individual increment, right? And now we should be able to say, gosh, if this works, I'll be amazed. We're now going to say int float. No, let's do int. No, let's do float. Float values equals Feigenbaum utils dot. Why didn't that work? Oh, it's because I've done the thing in the wrong way. Dot get Feigenbaum set brackets. Hang on, just be thinking carefully here. Yeah, so it is lambda. So lambda we know, and I think we can still start at 0.5f, and we'll set the increments to some iterations rather to something like 1,000. Okay, we're doing a very small amount at the minute. You'll have to bear with me on why that is. Okay, that's good. So that's got our values. Now let's say 4 brackets int. Let's say y equal for for each actually, for each brackets float value in values, then we say int yval equals brackets int, and we'll do something like this, value times height. Bear in mind, you see, the thing about this is that lambda is only going to be values between 0 and 1, which is great news because it means we can scale that by the height here. I hope that works. And then we'll say something like texture.setPixel w, comma yval, comma, so we say color.white, and at the end we say texture.apply. Okay, that's a bit of a chunky piece there. So what are we saying here? We're going through each of the pixels. Okay, the W there. Maybe change that to X. What do you think? PF2 X. Let's make it X. There we go. Okay, and then we can say lambda is that funky value that we've kind of worked between the start and the end. We've gone for that lambda there. We've set the starting point to 0.5, and we've gone for 1,000 iterations for each of the pixels. Spin back here, see if there's any weird errors. There's not. So in here, in start, we want to say, was it create Feigenbaum graph? Now I think there's going to be a bit of a problem. What I might just do here is just say, I don't think it's going to work. I was going to say debug.log, but I think it won't show because it'll be running. Let's tell you what. Let's just do that. Let's just set that to 100, all right? Which is nowhere near enough. But let's just run it now. So let's just give it a go and see what happens. Okay. Really? Have I messed something up? X equals 0.5. Okay, so I've switched that off, have I? Fine, yeah, that is true. We're not using those at the moment. Okay, click it. Here we go. Goodness gracious, guys, that's actually worked. Although weirdly, in my opinion, it's set the. It's gone from 2 down to 1, which has completely surprised me. One thing I've just realised, on my width plus, there we go. Lambda equals start val plus there, so we've got 2 to 3.3. Let's run that again. I was expecting that to be a white line going from that way and then splitting out. The good news is it's actually worked quite well. You can see it's actually split out. Now the question is, why has it done it that way round? So let's just have a think about what we've just done. We've said for width there, lambda is, well, we should probably take a look at this lambda, haven't we? Start val plus increment. I wonder if it's the other way around. Is it width over that? Width divided by. That's why. I think that might be why. Let's just try that. Okay, Shift Control S. Come on, baby. No, there's nothing. Bear with me, folks. I'll have a quick look and think about why that is. 1 second. Guys, I think I've worked out what it is. It's the rotation. No, not that one. This needs to be rotated 180. No, which one is it then? 0. Let's try rotating you 180. Which one is it then? I've tried doing that as 90, but then it doesn't show. 180? No. 270. That's the same as minus 90, isn't it? This is being a right monkey. Right, bear with me. I'll have one more try. Okay, so I think the problem lies in the fact that, like I say, this is upside down. I'm struggling to rotate it the right way though. So what I might actually do is go back into my scripts here, and we'll do a start coroutine here. Come on, be kind to me. Start coroutine. There we go. I'll just do that. And then this coroutine here, there needs to be an I enumerator, doesn't it? I enumerator. There we go. And what in here, I think. Yeah. So each time it does. Yeah, that's slightly. Well, I might just do texture.apply in here. Hang on. I do texture.apply there, and then I'll just say yield return null. I think that's going to work. It's all very fiddly with me, this. Right, let's have a quick look. Any errors? No, let's just clear that and run it. I'm hoping. Yeah, you can see it's starting on the right hand side. So this is good. I don't know why it's starting on the right. I think I've messed up my texture somewhere, but you can see it's drawing a very good. And it stops. Interesting. That's very interesting how it gets a lot longer, isn't it? Now it's taking a lot longer. It seems to be fine getting to there. I know why. I can tell you why. It's because it's got a lot more pixels. That's why. These are only returning 1 pixel, and this is probably returning a lot of pixels. Alright, so let's just do something a bit more funky. Let's just say... yeah, something like that. Texture set pixel. And then we'll say... int pixel count equals 0, and then we'll say if brackets pixel count percent equals, that basically means if it divides by 100, then we'll say texture.apply. Okay, it's getting a bit funky here, but this should give us a bit more visibility. Okay, and that's still going to yield return null, but it's only going to apply the texture every so often. Let's have another go at this. I also say pixel count plus plus, otherwise it'll never do it. What have I done? Int pixel count. What's wrong? Have I put percent if brackets pixel count plus plus? I don't see what I've done wrong. Is it percent 100? Excuse that. Sorry, is it that? Percent 100. Sorry, equals 0. Sorry. Gosh, I'm out of touch. And then over here, what have we got? Texture.apply. I was not happy about that. Only assignment called increment and decrement await and new objects can be used as a statement. As a statement. This is line 59,6. What? What? Oh, I haven't put brackets around them. I don't know how that happened. Right. Now how you doing? Comfortable? Yep, good. Right, now if we run it, I'm hoping it'll be a bit quicker. It'll certainly be quicker there because there's not many numbers. And it'll get slower as it starts to return more. I'm kind of hoping it's a bit quicker, isn't it? But nowhere near as quick as I thought it would be. Let's try 1,000 then. Yeah, I thought this was going to work. Texture... We should say value count, shouldn't we? Yeah. Let's try 1,000. That might be a bit better. It's happy with this. A bit quicker, but it goes very slow now. Much slower than I would have expected. Still going. You can see it here, look. Let's do one thing. Now that the lambdas are showing. By the way, I put this debug in. You probably didn't see that. I'll say plus. No, hang on. Let's do this. Hang on. Let's put it below it. Brackets plus count plus face quotes count equals plus values dot length. Let's just do that and just see how we're talking here. 1, 2, 1, 2, 1, 2. See, everything's good so far. 11, 13, 16, 23, 27, 30. See, so as it starts to rattle up, that's taking a long time. I thought that would have been not quite so bad as that. So now it's up to 100. I think 100 is the maximum, right? Because that's the number of increments that we did. It's just taking a real load of time to do it. There we go. You can see it's gradually doing it. Interestingly, What we may be able to do here, okay, is if we go to our Feigenbaum utils here. So we've got our get Feigenbaum set, okay. Let's add another thing called something like public int get Feigenbaum set as integers. Okay, so bear with me on this. Right, what we're going to do, I hope this works. So we'll have the same settings here. Alright, Control C, and then we'll just run that. And we'll also have a value, and we'll also have a value called int max value. Right. Okay. Now, I think I know what I'm saying here. Is what I'm trying to do is actually convert this to an array of integers. No, do you know what? Forget that. Sorry, guys. Let me just do that in here. Yeah. Should I do it in here? It makes sense here, doesn't it? So let's just do this. Let's just say for brackets for each hash set of type integer, int height values equals new hash set. And then we'll say for brackets for each brackets int float value in values. Okay, then we say that we say this y value here, right? And then we say height values dot add y val. Right, and that's going to go through them then, and it's only going to add the one. It's only going to add this one time then, and then we rather than do this, we can just now get rid of that, and we'll say up here int y val yes, y val in height values. Okay, let's just try getting rid of that now. Let's just get rid of that nonsense. Let's just get rid of that. Okay, so now in theory we've only got a set of y values, because what we're saying here is we're just converting them to heights, so there should be a lot less of them, again being a set. Alright, so we should have a lot less, and we'll have height values dot length. Alright, and so we're just going to have one value there. Let's try it. Let's try that. I know we're going the wrong way at the minute. We'll work on that problem in a minute. I just want to make sure I can get the what height values got count, isn't it? Because obviously it can't be consistent, for goodness sakes. Sorry, people. Nearly there. Nearly there. You see, it's got count of 1. It's definitely sticking to 1 now, isn't it? Can you see? Because it's that's better. Kaboom, and away it goes. Interestingly, okay, we're done. Okay, good. Now I don't know why. I can't get it to face the right direction. So I'm going to cheat. If you've got some thoughts on how to do this, I'm going to say where's texture.set pixel there? So I'm going to say width minus x. Okay, sorry. I think that'll do it around the right way now. Say round the right way. I'm cheating a bit because it's gone down though. I thought it was going to go up. There we go. It's going out like that. There we go. Oh, I know why it's gone. I know why it's gone. I know why it's gone down as well. It's because y starts at the top, not at the bottom. So we also got to do that, haven't we? So let's just do this. Let's just say, where are we? So we'll say height minus. There. So it's a bit of a cheat as well, really. But there we go. We're getting there. Right. So we've actually got. Look at this. There we go. It's zooming out. Right. So let's try this now. Now that we know that 2 is quite a long way. Let's try something like 2.9, and then we'll go to 3.6. All right. Okay. Here we go. Early on, you can see there's a lot of values. Can you see? There's a lot of values there, and it's a lot happier because it's kind of branched out quite a bit. And I'm hoping. Here we go. It starts to branch out again. and again, and again, and then if I'm right, look at the values now. Look at it. There's loads of them. 64, 68. So it's really struggling now. But you can see, I think, that it's actually. I tell you what. Let me just pause this and maximise on play. Unpause it. You can see it's starting to go very. Oh, blast it. Okay, we can watch it again. Here we go. Lots of values there, but then it zooms out. And guys, this is a Feigenbaum graph. What I would really like to do is actually make this texture a bit wider. I think I'll work on those little bits on the side. Maybe you could work out how to do those pieces now. You can see that it starts to get very, very upset around this point here. In fact, it starts to get very, very scattered indeed. But it is doing it. It's doing something rather funky actually. I rather like the way it's doing that. And you can see it starts to go very, very nuts indeed. Right, so let's just go crazy. Let's just do 3.4 and 3.7. Right, so there's not much in it. I think it's going to start taking a little while now. Actually, before we let me just do one thing. Let me turn off debug.log because I've noticed sometimes that can really slow things down. There we go. Okay, so we've got our split because we'd already done that. They are splitting again. Quite happy. Those values are so close together, you see that it's not too unhappy. But when there are a lot of pixels, when the split occurs, there's a lot more sort of meshing up there. What's interesting to me is these aren't a perfectly symmetrical break either, are they? Can you see? And things start to get very confused now. It's taking its time, but it's doing it. Possibly hammering my PC, but it's doing it. Am I recording? Please tell me, Lord, I'm recording. Yes, I am. And we can let this run. Yeah, we'll let this keep going and going and going. Let me try putting that back that piece that we did earlier on where it was applying the texture every 1,000 goes or something, wasn't it? So we'll just say int apply a value. It doesn't really matter, does it? Value count equals 0 semicolon, and then we say if brackets. I don't actually think this apply is taking any time, to be honest with you. Now I think about it, I think it's actually setting the pixels that's taking the time, but it might not be. So let's just go with it. If brackets value count. Not happy with that, is it? Count plus plus percent 100 percent. Let's say percent 100 equals 0. Texture dot apply. Right. So is that actually right? I've got a feeling something's wrong with it, but let's give it a go. I don't think it's any quicker. Thinking about it, I'm surprised it doesn't do it in chunks. I'm missing something on that value count, aren't I? I don't know what. Okay, away it goes. I'll tell you what I'm going to do. I'm going to pause this, and when it's finished, I will come back and we can take a look at it. One second. There you go. Oh, now you can see it's doing it in chunks now, which might be quicker. Don't know. So it's all overlapping and chaos is ensuing. Alright, so let me pause this, and when it's finished I'll come back. Okay, that's finished, and it took a little while. This is really interesting. I think that does actually coincide. I've closed the window down now, but this does coincide with what the other graph show, which I think is really interesting. So when as the lambda goes up here, about this period here, this gap appears. Now it's hard to know, obviously. I think I'm going to encourage you guys to perhaps graph this out, or maybe just work on logic to add these in here. What I thought I might do is a really quick fix, because I'm conscious that this is going on a bit long now. Is I might just add a text field. Oh no, not the thing. I'm going to create a UI text field, and we'll just call that something like lambda text. Right, and then what we'll do. Now where is it? Where is it? Has it got any text in it? Yeah, new text there. So why isn't it appearing on here? Perhaps we just need to click on here. Alt Shift, top left. There it is up there. Can you see? We'll make it white because I can't be bothered to change the colours. Let's make it white, and we'll also let's just bring in a bit. This is the annoying thing about this. This thing is so huge. Why have to make it quite as big as that? There we go. New text. We'll whack the font up to, I don't know, 72 or something. Too big. 36. Where are you? Oh, I need to do these. These bigger, don't we? There we go. Now we can make it 72 now. Okay, that's fine because no, let's make it 48 then. Ooh, that's still a bit big. 36 it is. I'll tell you why in a second. I think what we'll do is on our other script, which is Feigenbaum texture. At the top here, we'll say public text. UI text? Oh, sorry, let me say using Unity Engine .ui. There we go. And here, public text. Be kind. I've already done wrong. Come on, don't do this to me. Public text. There we go. We'll call this lambda text. Right. And then somewhere down here, I guess, we can say lambda text dot text equals lambda. Lots of lambdas, okay? And then back into here, and then we'll just go back to our plane here, and then here, I'm hoping that'll update. Come on, baby. Did I save it? I thought I did. Have I got a bug? Have I got a bug? Yes, cannot convert float to string. Okay, where's that? Oh, equals so it should be something like quotes plus lambda, something like that. Is that going to work? I have to hack it a bit. There we go. Okay, so now if we run it, it hasn't worked. In fact, it hasn't even run. Oh, because I didn't drag it in. That's why. Because you need on here, I'm going to need to drag my lambda text onto there. Okay, and now if I run it now, we can see the number going up. Okay, and it does go a bit slower, but you get the idea. And we can run this, and that, guys, is the Feigenbaum graph. Thank you so much for watching. I hope this has been interesting. It's one of my own tutorials based on a number file tutorial, which I'll put a link in below. Love you guys very, very much. Thanks for sticking it out this long. All the best. See you soon. Bye bye.